today's training. The title for today's training is Mastering Research Skill from Problem Solving to Effective Content Organization and Result Presentation. I'm your conductor today. My name is Chiang. I'm a senior lecturer in the Faculty of Mechanical Engineering in University of Indonesia. And I have to inform you that today's training will be recorded because it will be used as the HRD code accreditation assessment purpose. Okay, so the recording will be used for the assessment, for me mainly. So I understood that the two of you are indeed a postgraduate student. So before we start the session, perhaps we can let you introduce the two of you to each other, so that everyone in the room can know better what we are actually dealing with. And also, I would like to hear on the context of this training on the problem solving, content organization, and also the result presentation. Anything you would expect out from the training, perhaps, or what is the, also please highlight like share with us instead, I should say. What's the most difficult part in your research journey up until this point? So I think we perhaps can start with that first. So take your time. We would just like to know you more before we get started. So since there's only two of you, so I guess it will be easier. Okay, so perhaps we can start with Ms. Huang.
Okay. My name is Huang Chi, and I'm currently a master's student working on assessing the environmental impact of a renewable energy. And by joining this course, I hope that it could help me more in presenting my results and also organizing my content for a clearer illustration of what am I doing in my study. So nice to meet you.
Ms. Tan.
My name is Tan Min Hui. You can call me Mei Hui. I'm currently in my second semester of PhD research. And then my research topics involve mainly the plastic industry, the manufacturing and recycling part. So my main difficulties in research is that I am having problem to identify the research gap and leads to the problem statement. That's my problem right now, and I hope to get more insight from this workshop.
So if I understand correctly, finding the research gap probably is one of the difficulty that you guys are facing. And since you guys already started your postgraduate study for 1 year.
Yes.
Oh, yes. So I believe you also have gone through quite a few literature study. From there, hopefully you can find out the necessary information to form the research gap, right? So either is that, or you're trying to form the methodology that you need. Generally, all that can be classified as a problem. So we are simply just solving a problem. So what this training is about is to basically have a more standardized step to, I would say, pretty much solve any problem. So it's a very generic step, not necessarily applying to engineering field or any specific topic, but it's just on general how the problem can be solved. And a lot of time, problem cannot be solved, can be traced back to how we organize the knowledge that we can find out there. Because you read the literature to find information, some prior knowledge that can help you to establish some fact, and from there only you know what is missing for you to solve one particular problem. So if the information is not properly organized, then that's when the gap itself can be blended into the whole situation, and so it's not very visible. So all of these are therefore very related to one another. So they go hands in hands most of the time. Of course, if we have a simple problem, then it will be very obvious. For instance, let's say now you're hungry, you know you have to eat. So it's a straightforward solution. You don't have to go through this kind of sophisticated step. But the problem that most research are facing, academic research, especially industrial problem, most of the time is not as straightforward as that. It involves a lot of factors that may actually influence the outcome or the result. So, which is why a standardized step is always helpful for us to make sure we don't miss any or oversee any important information. Let's just put it that way. And of course, the last part of the training here we also put in the result presentation, because eventually once you compile all the information together, you find your research gap, you manage to solve the problem. How to communicate the result is also very important, because if you can't tell to someone what you have done, then is pretty much equal to you haven't solved it. So the result presentation is often a difficulty faced by a lot of people as well. So before we go into the actual content of the training, let's just go through what you can expect from this training. So the first would be on the problem solving itself. Okay. So by the end of this training, you'll be able to develop a comprehensive understanding and apply an approach called the hypothesis-driven approach for the problem solving. So as the name is very literal. You solve the problem by having a hypothesis first. Then only you solve the problem. So obviously if the hypothesis is correct, then your solution is you found your solution. Just like the very simple example that we say just now. You're hungry now. Then your hypothesis is, okay, I should eat to overcome the problem. Probably sounds dumb, but it is an hypothesis. And sure enough, you eat. And if you are no longer hungry afterward, then you solve the problem. But if let's say your hypothesis is, okay, now I'm hungry, I probably should go to sleep. Does sleeping help?
Why?
Fine, right? It might be a solution, see? So which means that there's more than one solution. So it all starts from making a hypothesis for solving. So that's what we're looking at first. And then we also have a exercise session, part of this objective as well. So that you, hopefully through the exercise, then you can apply the approach more easily from now on after the training today. So that will be the first objective. The second objective is on the content organization. So this training here aim to enhance your content organization skill, because you'll be reading a lot of literature. You'll find a lot of information, and everyone probably will be studying. The subject will be the same. Let's say Miss Paul will be looking at renewable energy. Okay. So they all probably start looking at renewable energy, but they're probably looking at different things. Some probably looking at manufacturing process, some probably looking at how it forms. So all this information somehow has to be organized in a very proper way that will lead you to the information that you achieve. And to that, we will use an approach called mutual exclusive and collectively exhaustive approach. MEC, they call it MEC. So it's a principle. It's again a principle how to organize information. So it's not just again applied to engineering content, but it could be applied to pretty much any subject in real life. And the third objective is on the result communication. So in this part, you'll be looking at you'll be acquiring the knowledge to identify the common pitfall for chart usage. So not all charts are created equal. I'm sure you plot chart before. If you use Excel, you go to the chart ribbon there, you can see all kinds of charts. And as long as you have data, you can plot pretty much all of them. But not all of them are showing the same thing. And their usage is very different. So that's what we'll be going into in the module 3, hence the objective 3. And once we're able to know the common pitfall, from there we will know which chart to choose so that we can tell what we really want from your finding. So that will be the main 3 objectives that we are going to achieve today. So along the session here, if let's say you have any question, so please stop me and raise it. So the first module here, we'll be looking at, we'll start from problem solving, because that's always the first task that we're always facing. So there's three sections under this module here. So we start by understanding the process of moving from problem to solution. So we find out what's the process first to solve the problem, and then from there we can look into the approach, or the technique that we will be looking at today, which is the hypothesis-driven approach, and then from there we go into which is the exercise here. So the process of moving from problem to a solution, okay, it sounds very easy. From we just need to find a solution, just like we find a solution, right? Simple simple problem need simple solution. But if now you change the context to your research, what would be can you name me one problem from your research that you can think of right now? Just any problem that related in throughout your. Of course, the objective here is to find out your gap in the end, help you to find your research gap in the end. But if let's say now I'm just asking you do the research definitely for a reason. You roughly should know what kind of problem you are solving. Okay, so if I'm asking you to name, just give an example of a problem from your research. What would you give?
To find out the environmental impact of a certain renewable energy in Malaysia. Just in Malaysia.
To find out the environmental impact of a certain renewable energy in Malaysia. Okay. And
My problem is not as specific as her. It was more like that I found out the plastic industry is very scattered and the key players that are not connected. So the system seems to be chaotic and they cannot solve the plastic problem together as one.
so I think fine. We're just using one example to proceed here. So let's start with the first one, perhaps. To find out the environmental impact of renewable energy in Malaysia. So obviously the solution will be something that can find this out because it's a straightforward question. Okay. So in order to do that, okay, it's a straight arrow still. Okay. But most of the time in the arrow here, it's almost like the diagram. Certain parts are shaded, which you probably know something. Okay. You probably need let's say, you need to know what the plant is actually, the renewable, what the material that actually used to build the renewable energy. That probably you need to know. And you probably also need to know how it is being used. Okay. So some of the information, you kind of know it because you perhaps seen it somewhere before. In fact, the second one is probably more obvious because you say that the information are scattered. And the fact that you know the information is scattered means you must have seen those information before. Because if you ask someone that never really looked at this problem before, they wouldn't know the information is scattered. So there are some facts which we see somewhere before. But somehow, to you perhaps, it still feels like something is missing. We still can't connect that dot to this dot entirely because the white color part is the one that is missing. So that basically is someone would call as the research gap. What's the missing part that actually helps you to connect from your problem to the solution? And the fact usually comes from diffusion. Because you read material, you read article, you hear from friend perhaps, that's also like global information. even though not really just officially recognized as an academic reference, but it's an information that you are actually you heard it from somewhere. So of course here will be, it looks very easy because this fact here stay here, this fact here stay here, this fact here stay here. But in reality, you probably get one information here, another information here, another information out there perhaps. It's not aligned, and you have much more information than these three pieces that actually contribute to connecting the problem to your solution. But nonetheless, if somehow you manage to let's say, organize those information, you can pinpoint that this tree is part of the process to solve or to link these two dots together. Then you can really identify what's missing. So that's how usually we start to solve the problems. And the gap here, the missing part. This is what your research question. So you can take it as, let's say this is fact 1, fact 2, fact 3. This gap 1 basically is to connect fact 1 to fact 2. And this gap here is basically to connect from fact 2 to fact 3. So when you write the research gap itself, this is how we pinpoint what is the actual gap. Let's say you do this, let's call this step A, B, and C. To solve this problem, whatever problem this is, you need to complete step A, B, C, D, E, and F. Then you can get to a solution. But the problem is now you only have step A, you only have step C, you only have step E. So your research gap basically will be, your research problem will be, there is no step. But that's just, again, very general way of saying it. We'll try to go into your actual problem in the exercise. But now I'm just trying to, if I may say, visualize how it can be looked conceptually. And because it's gap, which means you can't find information elsewhere from the previous study, the whole literature. Right? So really for us to move forward, we need to somehow, we can say guess what this step B is first. Right? That's perhaps the most logical way to start. And that guessing, scientific, of course, if someone just simply guess it out from blue, then it's really just guessing. But if we guess it based on some scientific ground, in other words, based on these three facts, maybe we already know the step A, C, and E, we can somehow guess the step B more closely, or at least it's a logical guess. So that kind of guessing, we call it the hypothesis. We hypothesize what the solution could be. So obviously hypothesis is a very academic word. Okay. Sometimes you may hear someone say that you make an assumption first. And throughout your 4 years degree time, perhaps all the subject that you learn through, especially those calculation subject, you very often you start with assuming this equal to 1. Then only you start solving. Right? Because you start with an hypothesis first. That hypothesis can be a fact first. Then only your solution. actually valid. That actually also got to say that if that assumption turns out to be wrong, your solution is wrong as well, actually. Right? So it's an assumption, it's a hypothesis, someone may think. So that is, I would say, the flow that move from problem to solution in the simplest form. So, of course, the actual problem always more complicated than this. So, hence, we have this hypothesis-driven approach. So it's a kind of like a framework, I would say, a standard step that you will do from one step to the other. You identify every block that could be applied here. Then slowly from one step to the other, from top down, you come up with your hypothesis. And then you know what needs to be done. Of course, you always start with an objective. Because you always want to have something to solve first. Then only you can start to, you must somehow have your problem first. Then only you can move on. So we start with the goal, the project objective is something. Before we even start to do any hypothesis, okay, we need to find out what are the key drivers, or what are the factors that could potentially affect the solution. So again, this part obviously has to come from the information that you collect before. From if you, let's say, want to solve a certain objective. Like for instance, the two objectives that I will just take this as your observations now. Right? To solve this, you probably already have a bit of clue what might affect this objective. So we have to separate the key driver first, the key factor first. We do this in a while. Okay. Probably I will give one more relevant topics or objective that related to everyone. Let's say the objective is to reduce obesity. How to reduce obesity? So this is our objective. So what key driver you can think of? Work out. More or less will come to later. Work out more is already a hypothesis. So it got to do with work out. Okay. Let's call it work out. Awareness.
Social pressure.
Social pressure. Let's call it happiness, maybe. Social pressure. Anyone you can think of? we stick with 4. If there is, they will just append it, right? Because you see, everything is very structured. So we have these 4 key drivers, let's say. Then from there, let's start make our hypothesis. So work out. How would you hypothesize how workout can reduce obesity? Workout more. Any more?
Have a more active lifestyle.
More active lifestyle. More active lifestyle. Sure. My handwriting is small because the camera cannot do everything. Any more? Work out more active lifestyle.
Work out
Regularly. Okay, let's say more as in maybe very intensive.
Yeah, very
Once a day, once a week. Yeah, then rest for the rest of the 6 days, right? Okay, regularly. Work out regularly. I think that's fine. Let's stay with 3 first. Okay. Then diet. Any hypothesis you may make that will reduce obesity?
Less processed food.
Less processed food.
Low sugar.
Low sugar.
Eating at constant timing.
Eating a constant timing. Running out of space. Any more? It's fine, I ran out of space. It's an example of it, okay? Just now is awareness. How about awareness?
Going to regular checkup.
Regular checkup.
Recognize the consequence of obesity.
I think it's fine. Let's stop there, okay? And social, maybe 1 or 2 hypotheses. Happiness, sorry. How happiness level or what's the word just now? Social
Social norm. Pressure.
social pressure, yeah. I'll make this low social pressure can reduce
Low social
pressure. Or live happily lah. Low social pressure, maybe it can be neutral, right? Not has to be happy, not has to be depressed. It's just low social pressure. It can be neutral. And whereas live happily as in
Being very happy.
it has to be happy. It cannot be neutral. So fine, it's our guessing. And what if I ask,
Which one is more important?
At this point, we are just formulating the hypothesis. Don't jump to the solution yet. Because at this point, if we start to jump to the solution, then it's a bit difficult for us to follow the step. But just curious. You don't seem to have any from making this hypothesis. Where this idea came from?
From reading.
Reading, right? You've seen this kind of information before. And in this context, those information that you seen before, maybe even from social media, right? From any video channel, YouTube channel, right? So those are your literature, but somehow you already have a lot of fact if you realize. Okay. And if we relate this, whatever we did here, to this again, okay, we still have one problem. It's the same objective, don't change. In the end of the day, we still need one solution. Okay? But instead of one line here, actually now we have 4 lines. We have the workout, we have the diet, awareness, and social pressure for happiness. So there can be 4 lines actually that solve that problem. It can be one of it that already enough to solve the problem. It could be more, need to have more than one. Or maybe need the all 4 of these, then only can solve. Okay. That later on until the end, but when we go into a solution, then only we will find out. But the main thing is, you already have a key driver. You know how many lines actually are connected. Okay. It's also assumption, right? Because we stop at social pressure. If we keep going on, maybe there are 5 lines, 6 lines. If we ask a doctor, perhaps a medical doctor, he or she probably will give us 10, right? But based on our, at least the reading from 2 already, at least it's 4. And then all these are the fact. Sorry, the hypothesis. Because you already somehow have the fact. Based on the fact, you already able to make the hypothesis. So from there, then we start to form the key question. Key question is, okay, we can take the example of the workout. Okay, obviously we go through all of it, probably it's a bit too much. Okay. Let's do here, the workout. Since everyone start to work out more and more nowadays, right? Okay. Work out regularly. If let's say you're going to conduct let's say you're going to conduct a control experiment. Okay. You really, let's say now you have 100 people. Okay, you're going to conduct the experiment, what they call it, the medical experiment. The control experiment to see the effect. When someone say you want that one person to work out regularly, do you think that person will get the idea of how much he should work out? You have to be more specific, right? So that would be the key question. So you have to frame it in more detail. Let's say is workout 3 days a week, 1 hour per day. Is it sufficient? Okay, so that will be a key question. So that there is analysis, but in this case here probably is that sample that one person have to practice this according to this key question here. Then later on we can look at how the result is. And so goes with the other. this is work out more intense, the intensity more. Okay, so how do you want to frame the question actually? Right? How intense it should be? Then maybe one day a week. Right? So that will be our key question. Same. So from there, we have our analysis of the medical experiment, whatever we call it. So you can see the step, right? At least I think it will be much easier to understand compared to whatever you actually do analyze it into engineering. So that is basically we call it a problem structure. So we structure our problem in a very systematic way. Even though this question sounds very simple. In fact, it could be as simple as we are hungry just now. But even that we can amplify quite a lot of. If we just put every the key question here, we will have almost 10 questions to answer. So which means we need to have 10 from here. Because we are conducting experiment, it basically means we need to conduct 10 experiments. The truth is like that. So after we conduct the analysis, then the process basically reverses. Okay. Until we get the answer, the recommendation. So the chart here is drawn side by side because they correspond to one another. You see the key question here. Once we conduct the analysis or conduct the experiment, we get the result. It becomes a fact. Once it becomes a fact, from there we get our finding. It's more or less the same function. But finding here basically refers to proving whether our hypothesis is correct or wrong. And then, if you see here, the next step up will basically be the conclusion. So the conclusion basically, in this case, is to answer whether workout will can help to reduce obesity. Will diet actually be helping to reduce obesity? So now, instead of top down, we go bottom up, because from the result, we go and find the recommendation. So if you relate that way, the objective or the problem just now is how to reduce obesity. So in the end of the day, after your social experiment, your medical experiment, you find out a recommendation. In order to reduce obesity, someone should do what? Does that sound logical?
Next question. What if some of the key drivers are connected?
What are some of the key drivers connected, right?
Let's say if one of the key drivers is someone's income level.
Sorry? One of the key
Someone's income level. And so having a low income, it relates to the choice of diet. It relates to whether he has time to do workout, and it also relates to his own mental happiness.
Living quality, I may put it away.
Yes.
True. Correct. For us to ideal situation, the key driver should be completely isolated, that they shouldn't interfere. The reason that it still overlap now is because we did organize it properly. So how to organize it? Actually, that's the important thing. So you see, it comes hands in hand. If somehow we can completely isolate the key driver clearly, then it wouldn't have any interference. Then the finding and therefore the conclusion later on can be more certain. Let's just put it that way. Because otherwise, like we say just now, the income level will affect the diet. So if from the diet itself, or I should say, later on from the income level itself, you find that low income, I'm just again hypothesize a conclusion that we get. Low income level will lead to obesity. Okay. Or high income level can help reduce obesity. But then we are not very sure was that because of the workout or because of the diet. Right? It starts to. That's when, especially as a student, a mature student, if I can put it that way, we start to write this kind of statement like this probably could be due to this effect and that effect. But somehow that student just can't pinpoint the exact conclusion out from it. Then the research is considered, the study itself is considered not complete. So that's the one thing actually needs to be avoided. So if you trace that back, which means from the beginning the key driver has to be clearly organized. And here you may see for the finding. Finding basically is to verify whether our analysis is correct or wrong. Not all the time it will be correct. Because remember, hypothesis basically just asks us guessing. I think take these two is a very, very obvious example. Any of you believe that workout very intense but not regularly? Okay, in between these two, one workout regularly and one workout very intensely but then once a week. Which one of these you think can we use? Regularly. Maybe if let's say there's another person, he or she might think, I work out one day, maybe I work out 3 hours. Right? Just one day enough. Enough for you work out 3 days, 1 hour a day per week. Right? So through our medical experiment, then we find the answer. So one of these bound to be, or maybe both are correct. You can do both. Right? So which means there's actually 2 methods to solve. So again, this is just on this part here, it's basically the analytical. So it can be, if this question that we're talking here is not this is not called social science, right? This is called health science, maybe, right? Health science, obviously, the only way you can conduct the analysis or find the answer, I'm guessing, is through medical experiment. But now, if this is let's say, some engineering problem, then sometime you might do experiment. You probably will go to the lab and do the experiment according to this question here. Or you might use simulation to find out. Either way, it can give, as long as it can give you a reliable answer, then you are able to do the analytical because you are basically analyzed. So basically, this is what a hypothesis-driven approach basically is. And if you really think about it, pretty much in any form, you can solve it. Some problem probably don't have much key driver. Let's say we go back to the question earlier, to the problem earlier. We are hungry. How many key driver you can take? Just it. We are hungry. Mentally hungry, right?
Physically hungry.
Physically hungry, mentally hungry. It's more straightforward. You don't have that much of key drivers. Well, as far as you can think of, it's either your mind over matter or you're actually hungry. Right? So you probably only have two key drivers. If you are an engineering problem, maybe you have more than 4 or 5. If it involves social science, human especially, the factor could be a lot more. So depend from problem to problem. It doesn't matter. Sometimes probably it's just one key driver. Then it will be really straightforward. So that is in a nutshell what a hypothesis-driven approach for problem solving. So we make the hypothesis first. We identify the key driver, which means we identify how many lines there is that lead from one to the other. Then we do the hypothesis. So with that, I think let's try some exercise, perhaps. Okay. Of course, I'm not expecting you to find until the solution itself, not to this side of the chart. But at least, if let's say we can come up with hypothesis, then you are able to formulate a few key questions. I think that will be good enough for today's training. Since we also don't have a time limit. So I chose two case studies, two cases here, since there are two of them. And the objective itself, here I put the objective, is actually based on your research topic. So for the case number 1 here, let's say we need to develop some sort of data set for a manufacturing process. It don't have to be this one that I put right here, but it happen to be this. I just try to be more specific because that might help you to pinpoint what the key driver could be. Whereas the second is to develop the inventory data of a renewable energy fund. The inventory data, let's say. Not to the extent of the environmental impact yet, we're just developing the inventory data. So if you may, could you quickly write a few key drivers that you can think of for the two of these? Then perhaps we can play from there. managed to get it? Managed to get it? Yeah, but it's a guess, right? So, which one shall we start with? Right? So, to develop some sort of data set for a certain manufacturing process. Okay. So, what will be the first key driver that you see?
The purpose of developing the data set which relates with the application level of this.
The purpose of it, which is
Relates with the scope and the overall level of ambitions that we are trying to achieve. And the source of data and the data sample size.
sample size. Okay. Any thought that may, sorry, key driver is not hypothesis. One thing that I would advise here, okay, when using this kind of approach, is don't worry ahead that the key driver might be wrong. Because if the key driver is wrong, doesn't matter. At first we don't know. We'll know it in the end. You just list out any key driver, any factor that you think that it will affect. Later on you do the analysis, you somehow find a way to prove whether that hypothesis is correct or wrong. If somehow all the findings are suggesting all the hypotheses under that key driver is wrong, obviously that will not be, let's say here is wrong, and wrong. Obviously that key driver will be wrong. Then you rule it out in the end. Because from the beginning, if you already limit yourself, you stop thinking what factor there might be. Sure, you will come out with hypothesis. You will never find out whether it's correct or wrong. So I'm not sure this is correct or wrong. Right? Obviously, the only way to find out is we prove it in the end. We analyze it. Then do it. Okay, so at the beginning, always list out as much as you can think of.
One more.
Yeah.
One more. Technology level.
Okay. Again, I also don't know whether this is correct or wrong. Just listen up. Later we'll form our hypothesis, then we prove it in the end. Probably I would say the resin itself, the material. Maybe I'm just guessing, right? It could be material, it could be. And also don't worry that it will become too much. Okay? Because if let's say we only start with 5 key driver here, each of it will have its own hypothesis. Then eventually a lot of things you have to study, right? And you see, this is exactly where the scope of your research. So we're only looking at the effect of material, let's say, the effect of technology level, the effect of sample size, let's say. Right? If, let's say, somehow you decided not to look at all, if let's say all of them are found to be true, or somewhere down the line, even before you start analyzing, okay, you decide, maybe I don't want to look at sample size, it's just too much for me to cover. So then it just means that in the end, you wouldn't get a conclusion that has anything to do with sample size. You can also limit yourself afterward. But when you brainstorm, this is everything, I would say. I think it's fine. Later on, if we thought of any, we can add anytime. And how about the second objective? What would be the key driver? The key driver they can.
The type of renewable energy
The type of RE.
and the location where RE is applied.
Location. Or just make it very simple, right?
And the advancement of that technology.
Advancement.
And scope, like the study scope
Sorry, there's the scope.
of the study.
I mean the life cycle scope.
Like what you want to cover in your study.
Okay. Excuse me. Okay. Well, I think let's stick with this key driver first. So after the key driver, then the next step is for us to come up with the hypothesis. So let's say we come back to this one. The first key driver. The first key driver is the purpose of the study, the scope and level ambitious to achieve the objective. So how can that lead to development of the data set for this manufacturing process?
Like, is it cover only one process or like the whole system process?
Okay. Maybe if we stick along that line, that will be under the scope, right? Maybe the hypothesis will be study at one facility will be sufficient to develop data set, something like that. That basically got to do with the scope. So one study is insufficient. Level of ambitions to achieve. If you can't think of it right now, never mind. Let's leave it blank first. Okay, on this topic, on this key level. Source of data.
Picture or field data.
So we can develop the data set using literature data. We can use literature data. We can use field data.
Or estimation, expert estimation.
Expert estimation. From expert. Let me just put sample size. Any hypothesis you can think of?
Percentage of industry.
Percentage of industry.
The sample size relates to the overall industry capacity. If there's 10 companies doing this manufacturing process, how many percent are we trying to collect data from? The 2 company or 10 company?
Okay, I get the idea. So if I'm going to put in the hypothesis, basically I will put more sample
The representatives.
more sample, improve efficiency, improve accuracy. It's a hypothesis, I'm guessing. Then we have technology level and so on. Perhaps we just stick with this since our mind is already here. If we switch, then come back, it will be difficult. So after hypothesis, then we need to start to ask ourselves the question: what we need to do to prove this is correct or wrong? That's basically the key question. Because from here, we ask ourselves what to do to prove this is correct or wrong. Then only we know what to analyze or what to validate. or what to study, then only we come out with the result, which is fact. So this one is, one study is sufficient. So it basically overlaps with this already, right? So it doesn't matter. Okay. So here, one study is sufficient. Okay. So then the key question will be, actually, I can't think of any key question. it's almost like we know what to do already, right? So I think fine. Then in that case, we can go to the analysis. In case we don't need additional question already, like later on, the fact here we know, in fact probably is a bit difficult because it basically just means that these two should be combined together. The combination of this this hypothesis and this hypothesis can answer the key driver of scope. I think this should be the scope. So we need this. So we have conduct the, which means none of this already. Then we analyze right away. If let's say something with a question, with a research question, let's say this tree, okay, the source of data, can use literature data. Then, in order to prove this is correct or wrong, what would you need to do? Not necessarily key question, that can be like an action plan as well, because it basically is in between your hypothesis and what you need to do next. So, doesn't look like there needs to be additional question here already. So, literature data, which means the action plan will be find literature and form the data. Same goes for here. Same goes for here. You know, we'll see you do it once you know what to do already. You do it, then you come back and answer, can we really form this data set using literature data? If yes, then I will just use the blue to design the right design. Okay, so let's say this is yes, this is yes, this is yes. So then you come back, so this will be the finding. Okay, so yes, you field data, actually this field data can be used to form LCI data. Field data can also be used. Then your source data will be the source of the data to construct this whatever data set can be based on visual data, field data, and expert. And I think another example is this, right? Because this is exactly opposite. One hypothesis say that one data set enough. The other say more sample, improve accuracy. So definitely one is correct, one is wrong. Kind of, right? Because they are the opposite. So when you so which means that in order for you to tell which of this is correct, you need to know which one is more accurate, correct? And therefore, there is actually a question that we should ask ourselves. What is the error? Right? If we're going to tell which one is more accurate, we need to look at error. Okay. Same goes for here. What is the error? Let's say of 10 sample, 10 company, I just random number. Okay. Then what will be the error? So obviously, if this error larger than, if smaller than this will be wrong. This hypothesis will be wrong. Then this is correct. Then you can get your conclusion from it. Does that make sense? Even for you guys?
Does it have to be a linear? Or can you find something, do some analysis and come back to fix the key drivers and hypothesis?
Of course. If it's complex enough, yes, we just did a iteration just now. Right? We merge these two together. So you keep refining, of course. Because the problem with this question here, I failed. Too little fact, too many gap. So our hypothesis at the beginning may not so accurate in the beginning. So we will keep refining, as always. The more fact that we have, the more accurate the hypothesis, or the better you can form your key driver.
How do you know when to stop digging?
When your objective is achieved. When your objective is achieved, you get the outcome they want.
No, I mean, there are many key drivers, which means there are many solutions, right?
Okay,
Many
I
possible
see.
solutions.
Okay.
when-
So how many we should identify, right?
and the degree of
That.
effort
Mhm.
that you should put.
That is a tricky question to answer. Because if I ask you to do this in 1 month time, the depth that you can go into is very different from if I give you 1 year. And if I give you 10 years, you probably have even more. Because every time you do, you get more fact. The more fact you do, the more you know, the easier that you can identify the key driver. So it's really difficult to answer that, to be honest. Which is why academic study always will have to be peer reviewed. You submit for journal. Is the expert in that field that will judge whether this makes sense and whether the study is, the depth of the study is sufficient. So yes, it's not a straightforward answer. But we can also put it in another way. Let's say from literature you manage to come up with 3 key drivers. Okay. The minute that you can identify the number 4, that for sure is considered novelty. because it's a new finding. If let's say from your literature study, there's only 3 key drivers being identified by all the people around the world all this time up until this point. If you somehow able to identify the 4th one, that is for sure a new finding. It's for sure a
possible novelty because it's not verified yet.
So obviously after this, you keep adding, right? Then from there you can tell which one is correct, which one you need to try to add perhaps. But all in all, don't forget, the objective has to be something you want to achieve first. Right? Here I'm just at least put 1. If from the beginning the direction is already not correct, then it has to be corrected first. Because it has to be the outcome that you actually wanted to find. Then only all of this will make sense.
That's another question. What kind of problem worth solving?
What kind of problem worth solving? I guess it varies from people to people. I'm sure by now you also realize the academician will say something very different from the industry. Because again, everyone looking for different thing. So unfortunately, if it's a academic project, like your postgrad study, you have to look at what academicians want. But also at the same time, don't simply ignore what the industry is looking for as well. Because if the academic study doesn't go into the industry, you will never find its use. Which means it basically means your effort actually go down the drain. So find the perfect balance between the two will be the key. Right. So next one. Shall we complete this real quick? Okay, but